Welcome! In this elementary calculus tutorial, what we're going to do is a number of geometric problems in preparation for calculus. So let's get started. Three vertices of a rectangle are 5, 2. So first we want to draw these. -1, 2, and -1, 4. What is the fourth? Okay, so think geometrically and prove algebraically. So 1, 2, 3, 4, 5, 1, 2. So we have a point at 5, 2. We have another point at -1, 2. So there, and another point at -1, 4. So there. And obviously the fourth point has to be here. So what are the coordinates of that? Well, the coordinates would be 5 and 4. Okay, so that answers question 1. Question 2. Two vertices of an equilateral triangle are 7, 1 and 2, 1. So let's find these points. 2, 1, 3, 4, 5, 6, 7, and 1. So these 2 points, all right? So now this is an equilateral triangle. So what you want to think of are, what are the possibilities for the third point of this equilateral triangle? Well, we've got a point up here and a point down here. Okay, but how do you want to think about how to find exactly where that third point is? Well, what I would suggest to you is draw a circle with center 2, 1. Okay, and that would look something like this. Of radius, the distance between here and here. Okay, now clearly that distance is 7 minus 2. So that's the radius of our circle, 7 minus 2, which is 5. Okay, so this distance here should be 5. Now if we do the same thing with a circle with center 7, 1, then what we would get is a circle with radius 5 passing through the point 2, 1. Okay, and so this would tell us, keep going, we get 2 intersections. This would tell us the coordinates of those 2 possible third coordinates of the equilateral triangle. Okay, so how do we do this now algebraically? So let's set up the equations of 2 circles of radius 5 with center respectively 2, 1 and 7, 1. So the first one would be x minus 2 squared plus y minus 1 squared is equal to 5 squared. Okay, so that's the circle with center 2, 1. Okay, now the circle with center 7, 1 would be this circle, x minus 7 squared plus y minus 1 squared is equal to 5 squared. Okay, now what we want are the coordinates of the points of intersection. And so to solve this problem, what we can do is subtract one equation from another. But now let's get a Mathematica picture of this as well while we're at it. And so I'll write contour plot. And then I can just put in the equation. And when I do that with contour plot, I need to put equals 5 squared. And then I need to enter a plot range in both x and y coordinates. I think I need to go a little bit wider here in the x and the y coordinates. Okay, so let's have a look at that circle. Okay, so there we have it. Now, so let's add to that another circle as in the other one. So I'll copy and paste. And the difference here is the x minus 7 rather than x minus 2. Okay, and so let's go a little bit wider in the x coordinates so we see all of that. Okay, so now they look like ellipses because I don't quite have the plot aspect ratio correct, so I'll change that. Okay, so now they look like two circles. Let's include also the centers of those. So I'll put this into memory as A, and then I'll put into memory a list plot with the list of the 2 points. And then let's show the two of those together. Okay, so there we have it. Here is the point 2, 1. Here's the point 7, 1. And these two intersections here are the 2 points we're looking for. Okay, and so now let's go back to our pen and paper calculation where we want to find the points of intersection here algebraically. So what we can do is take equation 1 and subtract from that equation 2, because we can see that these two things in both cases will vanish, which is what we want. That will simplify this tremendously. Okay, so we'll say subtracting x minus 2 squared minus x minus 7 squared has to be equal to 0 because these terms vanish. And so we can expand and factorize this. So let's go ahead and expand and factorize. But actually you can see that this is a difference of 2 squares. So the factorization is clear without first expanding. So we see then that we have x minus 2 plus x minus 7 multiplied by x minus 2 minus x minus 7, but when we distribute that minus over, we have minus x plus 7. So this product is 0. Okay, now in the first multiplicand, we have 2 of the x's. In the second multiplicand, the x's vanish. So this gives us 2x minus 9 multiplied by 7 minus 2 is 5. So let's put the 5 over here, and this is equal to 0. Okay, so we can multiply by 1/5 on both sides and then take the 9 over and divide by 2, and so we will get x is 9 over 2, which is equal to 4.5 or 4.5. Okay, so that's the x coordinate where these two intersections occur. Now let's find the y coordinate. So to find the y coordinate, what we want to do is sub back into one of these equations. So let's take the first one. So substitution into x minus 2 squared plus y minus 1 squared is 5 squared. And so we have 9 over 2 minus 2. And 2 is 4 over 2. That gets squared plus y minus 1 squared is 25, which is 5 squared. Okay, so 9 minus 4 is 5. 5 over 2. So 5 squared is 25. 2 squared is 4. So it remains to take this 25 over to the right-hand side, collect like terms, take square roots, and solve for y. Okay, so let's write the 25 over 4. Top and bottom multiplied by 4 gives us 100 over 4. So y minus 1 squared equals 100 over 4 minus 25 over 4, which is 75 over 4. Okay, now let's take square roots. So we have y minus 1 is equal to plus or minus the square root of 75 over 4. Now the square root of 75, since 75 is 25 times 3 and 25 square root is 5, so we'll get plus or minus 5 root 3 over the square root of 4, which is 2. And so that tells us then that y is equal to 1 plus or minus 5 root 3 over 2, but let's put this 1 over 2, so we'll call this 2 plus or minus 5 root 3 all over 2. Okay, and so going back to the diagram, the one with the higher y coordinate is the one with the plus in it. So our coordinates now are 9 over 2, comma 2 plus 5 root 3 all over 2, and then this one down here is 9 over 2, 2 minus 5 root 3 all over 2. Okay, let's move on to the next question. What are all the points whose x coordinate is equal to their y coordinate? Okay, so let's write the collection of points. If the x coordinate is equal to the y coordinate, then the points xy would be the points xx, where x is an element of the set of real numbers. But thinking about the possibilities here, well, that's true for 0, 0, it's true for 1, 1, it's true for 2, 2, it's true for minus 1, minus 1, it's true for minus 2, minus 2, and every point in between. And so you can clearly see that this is the equation y equals x. So we have a line y equals x. Okay, question 4. What is the x-coordinate of all points on the y-axis? Okay, think about this. Remember, we're thinking geometrically. If they're on the y-axis, what's the equation? Well, it's x equals 0. Question 5. What is the y-coordinate of all the points on the x-axis? So if they're out on the x-axis, then that's y equals 0. Okay, question 6. If the point AB is in the second quadrant, so this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. We go counterclockwise from left to right, from the positive end of the x-axis counterclockwise when we count these quadrants. We have 4 quadrants. Okay, this is the second quadrant. And so if AB is in the second quadrant, let's find it. Let's say it's there, AB. In which quadrant is the point A minus B? Well, A minus B is down here, because the minus B reflects about the x-axis. Okay, so it appears in the third quadrant. Okay, so that answers question 6. Next question, join the points minus 1, minus 2, minus 4, minus 2, and so on in order with straight line segments. Okay, so let's draw a graph. So minus 1, minus 2, somewhere there. Minus 4, minus 2. Let's say there. Okay, so we go from there to there. And then we go to 7, 2. So 1, 2, 3, 4, 5, 6, 7, 1, 2. So we go there. That'll look something like that. And then to 2, 2, 2, 2 would be here. And then to minus 1, minus 2. So back to where we started. Okay, so we've done that. Find the distance between successive points and then identify the geometric figure formed. Well, I don't know what this is called. There might be a typo in the problem, so I don't know the answer to what this is called, but let's find the distances between each successive point. Okay, so the distance between these two is easy because they have the same y-coordinate. But there's a distance formula. Okay, so the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared is the distance between the points P1 and P2. And so if we apply this here, since they have the same y-coordinate, this term vanishes. So let's say the distance between minus 1 minus 2 and minus 4 minus 2 is equal to the square root of minus 1 minus minus 4 squared plus minus 2 minus minus 2 squared. This term vanishes, as we said earlier. This difference here is 4 minus 1, which is 3, but we square it. And so that gives us 9 square root. So the square root of 9, which is 3. So this distance here is 3. Okay, next, the distance between minus 4 minus 2 and 7 2 is the square root of minus 4 minus 7 squared plus minus 2 squared and then square root. Simplifying this, we've got minus 11 squared is 121. Minus 4 squared is 16. Okay, 121 plus 16 is 137, so we just have the square root of 137. Okay, next distance. The distance between 7 2 and 2 2. Now they have the same y-coordinate, so this will be easy. So 7 minus 2 squared plus 2 minus 2 squared square root. This is the square root of 5 squared, so root 25 plus 0. And so this distance is 5. Okay, next, the distance between 2 2 and minus 1 minus 2 is equal to the square root of 2 minus minus 1 squared plus 2 minus minus 2 squared square root. And so here we have 3 squared is 9 and 4 squared is 16. So this is the square root of 25, which is 5. Okay, let's move on to the next question. Question 8. For the function f of x is equal to 2x plus 1, find f of 1. So f of 1, what we do here is we just replace the x with 1 and simplify. So 2 times 1 plus 1, this is equal to 2 plus 1, which is 3. Okay, f of minus 1 is 2 times minus 1 plus 1, which is minus 2 plus 1, which is minus 1. Question 9. For the function f of x equals 5, find f of minus 2 and f of 0.4. Well, you want to think about this geometrically. What does this represent? This says for any x, the output of this function is 5. Right? So it's a horizontal line at y equals 5. Okay, and so when x is minus 2, y is 5. And when x is 0.4, y is 5. So f of minus 2 is equal to 5, and f of 0.4 is equal to 5 also. Question 10. So we have a function g of t equals a t squared minus a squared t. Find g of minus a half and g of a. So g of minus a half is a minus 1/2 squared minus a squared times minus a half. And this is 1/4 a. Now there are two minuses here, so that's plus 1/2 a squared. Okay, good. Find g of a. So g of a, now in this one we replace all of the t's with a. So a times a squared minus a squared times a. And so this is a cubed minus a cubed, and that's 0. Okay, question 11. For the function f of h is 2h squared over h plus 36.85. Calculate f of minus 84.466. Okay, f of minus 84.466 is equal to 2 times minus 84.466 squared over minus 84.466 plus 36.85. So this is a calculator exercise. Now I'll jump on Mathematica and do this. So for the numerator we have 2 times minus 84.466 squared, and then all of this gets divided by minus 84.466 plus 36.85. Okay, so we have minus 299.668. Okay, question 12. Find the slope through the points. So we've got P is 1, 0, and Q is the point 3, 8, let's say. And we're asked to find the slope through those points. Okay, so the slope is given by y2 minus y1 over x2 minus x1. Now it doesn't matter which one you choose as the second or the first, but be consistent because otherwise you'll get the opposite sign. Okay, so we have 8 minus 0 over 3 minus 1, and so this is 8 over 2, which is slope 4. Okay, next question. 13. Find the slope through the points minus 1, 2, and 2, 10. Okay, same story. M is equal to 10 minus 2 over 2 minus minus 1. And so this is 8 over 2 plus 1 is 3. Okay, so 8/3 is our slope. All right, question 14. Find the slope through these 2 points. Okay, same story. M is equal to 5 minus minus 3 over minus 2 minus 5, and this is 5 plus 3 is 8 over minus 7, so minus 8/7. Question 15. Find the slope through the point 3.2 minus 4.1 and minus 1.5 minus 10.2. Okay, that slope is minus 10.2 minus 4.1 over minus 1.5 minus 3.2. And so we get minus 10.2 plus 4.1. So 4.1 minus 10.2 over, now I can clearly see this sum is minus 4.7. Okay, and so I just need to subtract 4.1 minus 10.2. For that, we get minus 6.1. And then 6.1 divided by minus 4.7 is 1.29, 787, and so on. Okay, question 16. For the line x plus 2y equals 4, find the x-intercept, the y-intercept, and sketch. Okay, so here's my x and y axis. Okay, so the x-intercept occurs when y is equal to 0. So, hang on, that's a 4 on this side. So x-intercept occurs when y is equal to 0. Okay, and so when we sub y equals 0 into this, we get x plus 0 is equal to 4. So x is equal to 4 and y is equal to 0. So this gives us the point 4, 0. So let's find that. 1, 2, 3, 4, 0. So here. All right, now let's find the y-intercept. That occurs when x is equal to 0. So if we sub in x equals 0 into this, we have 0 plus 2y is equal to 4. So we divide both sides by 4 and we get y is equal to 2. And so this gives us the point 0, 2. Okay, so 1, 2. It's on the y-axis, and now we can just connect those dots with a line, and you can see that it has negative slope. And so if I put this equation in the so-called standard form, then I have 2y is equal to minus x plus 4, and then I divide by 2, and I get y equals minus 1/2 x plus 2. So the slope is minus 1/2, which you can see right there. All right, great. So moving on to question 17. For the line 4x minus 3y equals 12, find the x-intercept, the y-intercept, and sketch this. All right, so x-intercept, when y equals 0, what we have then is 4x is equal to 12, and so x is equal to 3. 12 over 4 is 3, and so we get a point 3, 0. Okay, now if x is 0, then what we have is minus 3y is 12, and so dividing both sides by minus 3 gives us y is equal to minus 4. So that gives us the point 0, minus 4. Okay, we have 2 points, so let's sketch. 1, 2, 3, 4. So that would be down here. That's our y-intercept. And then our x-intercept at 1, 2, 3. So right here. And then we just connect those with a line. And there we go. Okay, moving on to question 18. Calculate a few points for the function y equals x squared and calculate and sketch the function on the interval minus 1 to 10. Okay, so y equals x squared, so a few points. Well, we've got the point 0, 0, and when x is 1, y is 1. When x is minus 1, we have minus 1 squared is 1. When x is minus 2, we have minus 2 squared is 4. When x is 2, we've got y is 4. Okay, so now that we have a few points, let's sketch. 0, 0, 1, 1, minus 1, 1, 2, 4, minus 2, 4. Okay, now that we know that this has a leading coefficient of 1, which is positive, it should look like a smiley face shape and have its minima down here when that square is least, which is 0. We want to connect these in that shape, and so we have this quadratic parabola function. Okay, now it says to sketch this on minus 110, but I don't have enough paper here to do that, so I would have to change the scale and redraw this. Let's say 10's out here, and so then I would call this y 100. Okay, and then down here, let's suppose this is 1. So then it's looking something like this in that scale, from minus 1 to 10. Okay, question 19. Calculate the average slope so average slope, if I remember this right, this is the difference in the endpoints. Y equals x squared. So we've got the intervals from 1 to 10. So I'll do the first one. So the average slope would be (10 squared minus 1 squared) over 10 minus 1. Okay, and so 10 squared is 100, 1 squared is 1, so 99 over 9, which is 11, isn't it? No, yeah, 11 times 9 is 99. Okay, so 11. Okay, I'll put this into Mathematica also, because we're going to do a bunch of these. So to do that, I think I'll just write a function. Now let's keep it simple. Okay, so we'll say it's b squared minus a squared over b minus a, and then I'll just enter into memory that a is equal to 1 and b is equal to 10. Okay, so we get 11 as expected. So then let's do the same thing with 1 and 5. So with 1 and 5, we're going to get 6. And then with 1 and 3, we're going to get 4. And then finally with 1.1, we are going to get 2.1. Okay, and so the idea here is using the fact that, let's see, where's our curve? Something like this. That the slope here is equal, the slope of the tangent is 2, but what we're using is a secant to estimate that slope of the tangent as x plus h gets closer to x. So the denominator here, as this denominator h approaches 0, the slope of this tangent, or the slope of the secant, becomes the slope of the tangent line, and hence 2.1 should be close to the slope of the tangent line at 1. Now, if we differentiated the function y equals x squared, so dy on dx is equal to 2x, and so this says f dash of x is 2x, and so then if we substitute in x is 1, f dash of 1 is 2 times 1, which is 2. So the slope of the tangent when x is equal to 1 is 2. So these are all approaching 2 as this number gets closer and closer to 1. All right, let's have a look at question 20. It is not possible to calculate the average slope over the interval 1, 1. Why not? Well, that's because our denominator in this calculation is 0. So let's say since denominator would be 0, and so we would get something undefined. Okay, and so to calculate this via first principles, you have to take a limit. So I'll do that via limits. So f dash of x is equal to the limit as h approaches 0 of 1 on h f of x plus h minus f of x. And in this case, we have the limit as h goes to 0 of 1 on h x plus h squared minus x squared. Now the x squareds in this vanish, and we have 2xh plus h squared. There's a h in each of those, and so that's 2x plus h once we have divided throughout by h, and as h goes to 0, we just get 2x. Okay, so that will give us 2x, which agrees with what happened when we pull down that exponent 2 and subtract 1 from the exponent. We also get 2x. Okay, thank you.